Now, there's another side, though. It's not all about expected future demand. There's another element of things that operates in much the same way, and that is, think about it, what would happen if you had a lower interest rate. And you can think about a lower interest rate or just lower financing costs, whatever. A better, you thought that financing was going to be better. Now, what would be the effect of the lower interest rate on the market, the way we've structured it? So if you think about it, in our model, the way we set up the steady state framework, we had our demand for housing, and we had our steady state supply, which is 1 over delta I of R times 1 plus R over R plus delta. That was our steady state. And this is K bar, this is R bar. Well, a lower interest rate would do what? Well, a lower interest rate would imply a higher price for a given rental price. Right? Everybody understand why? That is, if you lower the interest rate, a given flow of rents is going to be worth more because it's going to be discounted less. That has the effect of, at any R, shifting this curve to the right. Right? So a new steady state would be over here somewhere. R double bar and K double bar. But think about it. So in this new equilibrium, R double bar is less than R bar. K double bar is greater than K bar. I double bar, which you can't read directly off this graph, but we know if I'm going to sustain a higher capital stock, I got to have higher investment. They're proportional in equilibrium. It has to be greater than I bar. And P double bar, therefore, has to be greater than P bar. That is, a lower interest rate kind of looks like this boom period too, right? Because a lower interest rate basically raises the price that the sellers get, but lowers the monthly cost of living in the house, right? I can afford more house when the interest rate's lower, right? My monthly payment on my mortgage is going to be smaller for a given house value when the interest rate is lower, right? That's exactly what's going on here. So whether it's a rental rate that some guy's charging me or it's the implicit rental rate for somebody who bought the house, a lower interest rate kind of has this same feel. It's a kind of a boom for these kind of assets because it raises the present value holding the interest rate fixed, the rental rate fixed, which causes the supply side to build more, which actually pushes down the monthly cost. Okay? So that's kind of the equilibrium that one would see. And whether you, and I think that was also an important part of what was going on. We had not just lower long-term rates, we just had more liquid financing in general, greater access to people to borrow money to buy housing and things like that. You know, the federal government had committed to help more people buy houses. And that all works in this same direction. And if people expected that not just to be short-term but long-term, that would have that same kind of boom effect. So I think if you really want to understand the housing market in particular, I think the combination of low rents and kind of simpler financing or lower cost, at least to the participant financing, maybe high cost to taxpayers, but lower cost to the participant financing is part of the story, not just high anticipated future demand. That people thought, well, the government's subsidizing people to buy houses, they're going to continue to subsidize them in the future. No, if lowering R really was, if R was lower and it was permanently lower, you'd get a boom. And it would be, what would happen, I mean, what the dynamics would be pretty straightforward, right? Because what would happen is, think about it. Here's R bar. Let's assume you had this unanticipated increase in interest rates. Decrease in interest rates at T. So I'm not going to do the expectations. The expectations are going to be just like the ones we had before pretty much. But let's just do the unanticipated case just to remember what the dynamics look like. So what happens? What happens? Well, R goes down, little r. Now we're talking little r, not big R. Little r, the interest rate goes down. Well, there's going to be no change in the rent right away because supply and demand in the rental market hasn't changed. The use market is what it was yesterday, right? The interest rate doesn't come in there. You might say, well, people feel richer or whatever, but let's just leave that out. Our demand curve, the demand for places to live hadn't changed. So R doesn't change, but P is going to go up, right? Right? P is going to go up, so I is going to go up, right? So I is going to go up to I bar. Oh, I'm sorry, I 0. P is going to go up to P 0. Now, what's going to happen to K? Well, K is not going to jump. K is going to start to grow. Now, where are we going? That always helps. Well, we know where we're going is we know that P is going to go up. But remember, what's going to happen to R from now on? Think about it. R is going to be going down, right? Because K is going up, R is going to be going down. Since R's are going down, P is going to be going down here, right? P is going to be going down. So P is going to come into its new steady state from above. So immediately, you would say this model doesn't, a one-time today fall in financing costs doesn't really fit, right? Because what's going to happen is P is going to jump up, I is going to jump up, so that looks like a boom, but P is going to be coming down because people are going to say there's going to be more and more housing, right? Which means you're going to have some expectation that not only is R down, but that finance is going to get even better in the future, that the future R's are even lower or something to make. Now I is going to come down and K is going to go up. It's a usual convergence pattern, right? We're going to converge to a lower steady state like that. All right, so that would be my pattern, would look something like that. That would be the pattern that you would get, okay? So you can pretty see if we're going to really have this boom period that has this other feature that we talked about before, which is like rising P, right? To get P rising, we're going to need to have like either future R's are going to go down or combine this with a demand increase. We're going to need something that says the future is better than today. If that wasn't realized. Or yeah, or it was realized for a time, but people thought it would just continue to get better and better, right? The idea was Fannie Mae, Freddie Mac, they were just going to crank out loans forever and just keep subsidizing more and more people to buy houses. And what we found out is they were only willing to dig a certain amount of a hole before they decided we can't do this anymore, right? Or somebody decided they wouldn't let them do it anymore. All right? Yeah. One question is, in all these pictures, we've drawn these convergence dynamics, right? We've drawn this dynamics of you converge to the steady state. What determines, let's say in terms of a half-life, how quickly you get to the steady state? What would be the most important? Did we talk about this? I don't think we did we? What are the most important determinants of how fast you approach the steady state? What? I would measure it by like the half-life. How many years it takes me to get halfway to the steady state. Because for models like this, they kind of have this exponential convergence where there's like a half-life. Yeah.
Yeah, I was going to say it seems like a single order exponential.
It is. That's why you can talk about it as a half-life. It doesn't matter how, like if this is a linear model, it doesn't matter how far away I am, I'm going to close half the gap at some rate. Well, actually, the interest rate doesn't matter too much. The biggest one, depreciation rate, hugely important. Because depreciation rate is how fast, if you had a non-economic model, if you had a model in which I was constant, that is, there was no response of I to the market, you would converge at delta. Delta would be the convergence rate. Because you would just, the only effect is on depreciation, and the farther you are away, that's how much less depreciation you are. You get exactly delta would be the convergence rate, right? Right? Because it's an equation. It's like K dot equals minus delta K plus I. Well, everybody knows, I mean, how do you solve that? That is a linear differential equation that has a solution that has like e to the minus delta t as the solution. So it's going to converge at rate delta. So delta is an important determinant right off the bat. But what else? It is really simple. The answers are actually really simple. Okay. Yeah. More elasticity of supply. Absolutely. Faster. Right? The faster. That's an important determinant too. That's really important. I might even say that's more important than delta. Delta is like a lower bound convergence rate, right? Even if you had zero supply elasticity, you'd converge at rate delta, right? What else? Well, we already got the supply elasticity up there, guys. What do you think the other one has to be? If it ain't the supply elasticity, it's got to be the demand elasticity, right? And less elastic demand is going to mean faster. Should have guessed that even without thinking, because if more elastic supply, well, it doesn't always go that way, but that's probably a good guess. But why? Well, if demand is less elastic, then when you reduce the stock, rents go up even more. If rents go up more, then prices go up more. And if prices go up more, you're going to converge faster, right? And in simple models, it's actually the ratio of elasticity of supply to the elasticity of demand is what shows up. Okay, it's the ratio of those two elasticities. Okay? So those are the key factors. Now the interest rate is kind of interesting. The way that, remember when I talked before about this anticipated increase in demand? And I mentioned that, well, you don't, in the way I did the equilibrium, you built some of that demand in advance and you didn't, and you built some afterward. Right? We didn't completely satisfy the new level of demand. We didn't get to the steady state, even if we learned like 1,000 years in advance. Right? Even if we learned that demand was going to go up in 2006, 1,000 years earlier, we still wouldn't build the new steady state stock by 2006. And indeed, in these simple models, you never even build half of it. You build a little bit less than half, and the interest rate would actually determine how much you built in advance versus how much you built afterward. And there's an easy way to think about it, and it's like this. Look, what you'd like to do if you had perfectly elastic supply would do what? Well, you just maintain the old steady state until you got to 2006. You just build a whole ton of stuff on 2006, and then you'd satisfy the new level of demand. Now, if you can't build perfectly elastic, then you have to spread that out. There's a cost to spreading it out too early because you're building houses you don't really need. And there's a cost to waiting too late because now you're not satisfying the new level of demand. And what usually happens in economics happens in this case. You kind of share the pain. You do some too early and some too late. Now the interest rate comes in because doing stuff too early happens earlier in time. Doing stuff too late happens later in time. And the interest rate determines the rate at which I'm willing to trade those two things off against each other. So if there was a zero interest rate, you'd kind of like want to do half your pain beforehand and half your pain afterward. But if you got a positive interest rate, you're going to say, well, I'd just rather suffer a little more after the fact than before the fact. Then you kind of don't get halfway there by the time. So that's kind of how it works. The interest rate is the biggest role to think about it is its biggest role is determining the importance of the future versus the past. When the interest rate is low, the future is almost as important as the past. When the interest rate is very high, the past is much more important than the future. That's really what happens. Now, if you think about this from a mathematical standpoint, it always works out that way because you're going to, if you look at the roots of these differential equations, they sum to R. So, and the one that goes forward is a bigger in magnitude than the one that goes backwards, but because they sum to R, the positive one is like what is it? 2R bigger than the small one or whatever. I can't remember. You'd have to solve it out, but that's how it works. Yes. So if we want to do this model in continuous time, it's very similar actually. Equation 1 is the same. It's just k of t, because k is now just a function of t, right? That's in a continuous time world. K of t equals d of r of t. Right? Everybody agrees with that. That's just saying the amount we have is just the amount people demand at the current rental price. Number 2 is very similar to what we had before. P of t equals the integral from t to infinity. So we're going to integrate future rents. We're going to discount at e to the minus r plus delta tau minus t, r of tau d tau. That is, today's capital price is just the present value of future rents discounted at r plus delta, just like we had before. That is the same formula we had. It's just once you're exponential, you're just adding them together rather than getting 1 minus delta over 1 plus r. Same notion. Number 3, exact same equation we just had. I of t equals I of P of t. And for K dot of t equals minus delta K of t plus I of t. So those are my 4 equations, okay? They look very much like the equations I had, right? There's not much difference, okay? And remember that other equation I had, the other version of this equation? That equation is r of t equals r plus delta P of t minus P dot of t. Okay, let me call that equation 2 prime. That is, r of t, the rental price at date t, is interest and depreciation on the capital price minus this reevaluation term, minus P dot, right? Which is the same thing we had before. The higher the price, faster the price is going up, the lower the effective rental rate is for a given price, okay? Now, one thing you want to keep in mind, and this actually is going to turn out to be critical in a minute, is this equation here. People often think of this as like a primitive. It really isn't. This equation, how do you get this equation? How do you get this equation from this equation? Does anybody know? How would you take this equation and get that one? Just differentiate. Remember, this equation holds for all t. This is one of those equations we talked about before. This equation is true at all t, so I could differentiate both sides, right? That is, if two functions are always equal, then their derivatives have to always be equal, right? They can't be equal they can't stay equal if their derivatives aren't equal. So you could differentiate this with respect to t. But if I differentiate this question to t and say, well, this function being equal to this function is equivalent to the derivative of this function being equal to the derivative of that function, that's not true. They're not equivalent. That is, this equation implies this one, but this one doesn't tell you that one. There's a boundary. We threw away a boundary condition when we replaced 2 with 2 prime. Right? We threw away a boundary condition. So if economics determined a unique solution to these equations, and I replace 2 with 2 prime, I'm no longer going to get a unique solution. Not because there really are other solutions to this original problem, but because I've left something out. But you understand that? We're going to get a bunch of solutions that aren't really solutions to the problem we're interested in. Because we threw away one of the restrictions that our model imply. And in particular, what we threw away is the restrictions that prices are at the right level. Right? That's the important restriction we threw out. Right? That's a critical way to think about this model. if I'm only going to impose this, and this, then I threw away one of the most fundamental restrictions economics imposes, which is the level of prices has to be set at the right level. Otherwise, you ain't going to have an equilibrium. Right? People understand that? It's not like I'm bringing in some esoteric, crazy condition that I made up and mathematicians thought up or whatever. It has nothing to do with that. It's that there's this restriction that the level of prices has to be correct. I've just ignored. I've just said, okay, fine. I'm not going to worry about that for now. Well, you're going to ultimately have to worry about it, okay? I'm going to use 2 prime. And I'm going to use 1, 2 prime, 3, and 4. Remembering that when I use those, I left something out of my model, right? That's important, all right? So, what am I going to do? I'm going to make a graph in which I'm going to put K here, and I'm going to put P here. It's a lot like my old graph, but the big difference is I am going to put K and P rather than K and R. Okay? All right, so if I put K and P, how do I do that? Well, I'm going to substitute this equation into here. I'm going to substitute from here, I'm going to substitute in terms of R. Okay, so I'm going to have 2 equations. One, let me call it equation 5. My first equation, equation 5, is going to be K of T is equal to D of R plus delta P of T minus P dot of T. Okay, everybody? Okay, that's my one equation. That combines 1 and 2 prime, right? I've used 1 and 2 prime now. 1 and 2 prime. And then, equation 6, I'm going to combine 3 and 4 by substituting in here. I get K dot of T equals minus delta K of T plus I of P of T. Okay? That uses 3 and 4. Okay? All right? Now, what I've done successfully is I've gotten rid of I and R, and I got everything in terms of K, P, K dot, and P dot, which means I can draw a phase diagram. Everybody seen a phase diagram before? The phase diagram is a diagram that tells me how K and P will move starting from any given point, right? Because I can calculate K dot and P dot by solving these equations. You give me a K and a P, and I'll solve these equations for K dot and P dot. Actually, it's not that hard to solve, because if you give me a K and a P, K dot pops right out of 6. And if you give me K and P, then I just figure out what P dot has to be to make this work, right? So it's pretty straightforward. Now, whenever you draw a phase diagram, it's always useful to look at the equations K dot equals 0 and P dot equals 0, right? Those are the two places where K is constant and P is constant. Well, let's first do the K dot equals 0. Well, that's pretty easy. That just looks like my steady state supply equation, right? That's where I'm producing exactly enough to offset depreciation. So my K dot equation looks K dot equals 0. Now, how does K move on each side of that curve? Well, if I go up, that's going to increase I. So above this curve, I is higher, so K must be going which way? K is going to the right here. And down here, K is going to the left, right? Everybody agrees? Yeah? Now, what does the P dot equals 0 equation look like? Well, P dot equals 0 is like the steady state demand equation. It's like a steady state demand equation. It slopes down. It comes through here. This is P dot equals 0. Now, what's interesting is how did the dynamics go? Well, if I'm below this curve, then P is low. If P is low, then I got to make P dot low in order to compensate, right? I got to make them make up for each other. So below this curve, I'm going down, and above this curve, I'm going up, okay, like this. And down here, I'm going down, okay? So now, if I'm going to get to my steady state, how do I have to get there? Well, I got to get there like through here. There's going to be some stable manifold. This is a saddle point type graph. So the stable manifold is going to come in like this. I got to be coming, P's got to be falling and K's got to be rising if I'm coming in this way. And this way, I'm coming in this way. Okay? All right? Now, you might say, what would happen if I started above this line? Does anybody know what would happen? What would happen? I'm going to go here, and then eventually I'm going to hit this curve, and then P dot's going to change sign, and I'm going to go off that way, right? Because this is P dot equals 0, so I got to be moving horizontally here. And here, I'm going to go like that, right? That's how the equilibrium is going to look. It's going to look something like that. Now, you might say, well, geez, if I start at the wrong point, I'm going to blow off to infinity. I'm going to go off way up here or way down there. But now you're acting as if I can just start at any old point I want. But remember, economics doesn't say you could start at any old point you want. Right? Economics says you got to start with the right P. You can't start with the wrong P. And the idea that you have to start with the right P is exactly the idea you have to start on that line. Because that's the only point that's going to make the present value of rents equal to the present value equal to the price. These paths do not satisfy 2. They satisfy 2 prime. But the only path that satisfies 2 is this. Now, the ones that move you along, these paths are not irrelevant. These are the paths that happen when you have an expectation of things that are going to happen in the future. So let's assume demand hasn't changed today and the price rises. So then what happens is you move up to one of these paths that are going like this. And you follow that path for a while. That's the boom period. The boom period is this period where we're moving up like this. And then eventually what will happen is then this demand curve will shift. You'll hit the straddle path for that new equilibrium, and then you'll move down that one. So you'll link this unstable trajectory up to a stable trajectory. So I'm not saying that this path is irrelevant. It, in fact, would apply if the future was going to be different than today. But still, even in that problem, there's a unique price you can start with at the beginning. In that case, you have to find the starting point that when it goes along this explosive path, it hits the saddle path at the right date. Right? So what happens is, if I have to hit the saddle path a very long time from now, then the price can only go up a teeny bit because I have to take a path that takes me very slowly toward that new saddle path. Everybody see what's going on? I got to converge that new saddle path real slowly because I got to hit that saddle path. Now, when this path hits the saddle path, it's going to hit it closer to the new equilibrium than this one does, which means the further we're learning in advance, the more we're going to build in advance. The closer we're going to get to the new steady state. And that was the point I was making before. So you see how it works? So you can actually, I don't know if you guys do this in your other classes, but you could actually link up. You could figure out how you get there. Now, when you want to solve one of these problems on a computer, the way you solve them is you guess a price, and you look at what happens, and you say, whoa, that price was too high. And then you guess a little lower price, and then what happens is, and you'll never find one that really gets you to the steady state. What'll happen is you'll run the model forward, and you'll get really close to the steady state, and then at the last minute it'll just fly off on you. And that's what'll happen. But you're getting close to the right solution if you can approximate that steady state for a while.